Hi, welcome back to Moose Chemistry. This is electron configuration of boron lesson. Alright, so boron is the fifth element on the periodic table. So we're going to put a 5 right here. Okay? Right, 5 right there. And boron's atomic mass is 11. So we're going to write 11 right there. So that tells me that boron has 5 protons, 5 electrons. And what about our neutrons? Well, we're going to go AMU minus protons to give me neutrons, okay? So you go 11 minus 5, and that will give me a total of 6 neutrons, okay? So we're going to put a 6 right there. So now, before we start the electron configuration, let's remember that S can hold 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. Also, we're going to start right here at the top of the diagonal rule, and we're going to work our way down until we run out of electrons, right? So we have 5 electrons, so let's go ahead and start this. 1s2, okay? Now we're going to slide down this slide here, and we're going to get 2s2. So then we're going to come back to the top of the slide again and go down to this one right here. 2p1. Because 2 and 2 and 1 make 5. So that's our electron configuration. What about our orbital notation, or Hund's rule? Okay, remember that S can hold only one subshell. So you're going to have 2 electrons in that. So up arrow, down arrow. 2s, up arrow, down arrow. Now we're going to go 2px, 2py, and 2pz. Oh, so now the question remains, do I really need all 3 of these blanks because I only have 1 electron left? And the answer is yes, I do. Because electrons, they can become excited and they can jump suborbits, or they can actually jump orbits. So we're going to put 1 up arrow there. So now, what about our noble gas notation? All right, like the other elements like lithium and beryllium, the noble gas notation for this is also going to be helium. So we're going to write He right here. All right, and then we're going to write 2s2, 2p1, because they are our valence shell. All right, now let's do our quantum notation, our Qn. Okay, so let's look at that quantum notation. We have N, L, M, and S. Now, boron is not in the S block. No, boron is in the P block. It's the first element in the P block. So we know we have a P block element. And that's going to be very, very important to us when we look at our L value and M value. All right, so now, what energy level is boron in? Well, boron is in the 2nd energy level, so it's going to be 2. It's in the L value, it's in the P block, so the value is going to be 1 for the L. Now, it's the first element in the P block, so we're going to use -1 right here. Let's look at this last arrow right here. What is that last arrow doing? It's going up, right? Pretty snarly, huh? So that's going to be 1/2 positive, just like that. Well, that's it. You guys be snarly, and we'll see you back here at Moose Chemistry.